Okay, now we're going to talk about, we just finished 6-1, now we're going to talk about 6-2. So in 6-2, let's look at this over here, these two triangles. It says ABC was dilated to produce its image A prime, B prime, C prime. How can you tell this is dilation rather than rotation, translation, or reflection? What do you think? Okay, well, do they have the same shape? Yep. Do they have the same size? Nope. So they're the same shape but different sizes, so it can't be rotation, can't be translation, can't be reflection, right? Those all have the same shape and the same size. Which of the 4 points, P, Q, R, or S, is the center of dilation? P, Q, R, or S is the center of dilation. How can you tell? If we're going from ABC to A prime, B prime, C prime, what do you think is happening? I'm going to let you take a guess for that, okay? Now let's talk about finding the lengths. The lengths of all the different sides on both triangles. Let's do the easy ones first, right? We can just count from B to C is 2, and from B prime, C prime is 4. So let's just start with the easy stuff. But now we got to remember how to find the length of these slanted sides. So let's use Pythagorean theorem, otherwise known as distance formula. So if we count, if we're going to do AB, if we count over, let's see, if we count over 1, 2, 3, that's 3 on the X, and 1, 2, 3, 4, that's 4 on the Y. Pythagorean theorem, 3 squared plus 4 squared, and then take the square root. That'll tell me how long that side is. So 3 squared plus 4 squared, and then take the square root, it equals 5. So that side right there is 5. Because 9 plus 14, or 9 plus 16 is 25. And you'll notice I already did that up here. For this one, if I use a different color, I go, okay, 1, 2, 3, 4, 5, 6, to go up to 1, 2, 3, 4, 5, 6, 7, 8. So then we have 6 squared plus 8 squared, and then take the square root, and we get 10. So let me erase that line, because it's just a little bit too much to look at right now. A little too much going on. But we just figure out how long that side is, Pythagorean theorem, right? Okay, I need you to do the same idea and figure out AC from A to C. How far left and up, and then use Pythagorean theorem, and then A prime to C prime, left and up, or right and down, however you want to look at it, and use Pythagorean theorem. Hopefully, you got that AC is 4.1 and A prime C prime is 8.2. How many times bigger is the image than the pre-image, and how do you know? All right, similar idea. Get rid of this up here. Find the slope of A to B. Oh, we got to remember slope. Slope is the rise over run, or if you subtract the y's over subtract the x's. So if we want to figure out the slope from A to B, we're going to have to do a similar idea where we think through, okay, well this was, except this time we always go to the right. So it goes down and to the right to get from B to A. So it goes down 4 and right 3. Down 4 and right 3. So that slope is -4/3. What's the slope of A prime to B prime? Well, it's going to go down 1, 2, 3, 4, 5, 6, 7, 8, down 8, and right 1, 2, 3, 4, 5, 6, right 6. So that slope is -8/6, which is also -4/3. You calculate now the slope from A to C, from A to C, and from A prime to C prime. And you should have got down 4, right 1, which is -4, down 8, right 2, which is -4 as well. What do you notice? All right, compare the angles in the pre-image to the angles in the image and make a guess, an educated guess, conjecture about the relationship. What do you think is the relationship between the original, if we go back, the angles in the original triangle and the new triangle? Do you think you can prove it? All right, so quick notes on your paper, 6-2 quick notes. Dilations enlarge or reduce a figure from the center of dilation. If the center is 0, 0, it's nice and easy. All we do is we multiply everything by our scale factor. If the center is not 0, 0, it's a little bit more complicated. Dilations are not rigid. They change size by a scale factor. Angles and ratios of the sides stay the same. All the angles stay the same. If you know the angles in the first figure, then you will know the angles in the dilation. The lines stay parallel or have the same slope. The center of dilation is the only point that does not move. The point that does not move. So let's do some examples. Quadrilateral ABCD was dilated to produce its image A prime, B prime, C prime. So ABCD was dilated to get this little guy. Is that enlargement or reduction? Reduction. What's the center of dilation and how do you know? D is the center. It didn't move. D is the same as D prime. So the center of dilation was D. Find the scale factor. Okay, now to find the scale factor, we need to know, we need to compare the whole length of the new and divide it by the whole length of the original. Well, to find the length, we're going to use Pythagorean theorem again. So do that. Find Pythagorean theorem of this guy, and then Pythagorean theorem from A to D. Or you could do B prime, C prime, and B and C, but you just pick a side on both. I chose A to D and A prime to D prime, and that was 6 by 6 from A to D. So that's why this has 6 squared plus 6 squared. And that's 72, square root of 72. And from A prime to D prime was 2 on that side and 2 on that side. So that's why it says 2 squared plus 2 squared. And take the square root, grab a calculator. Turns out it's 3. Now if you're going, how does that weirdness turn out to be 3? Long story, but if you don't believe me, if you rounded it in your calculator, if you did square root of 72 and square root of 8 and then rounded them really early, it would give you something close to 3, but not exactly 3. But if you did as far out as you could on both those estimates, it would get you pretty darn close to 3. Now part D, it says, find the measure, if the measure of angle B is 98 degrees, find the measure of angle B prime. They don't change, so measure of angle B prime is still going to be 98. All right, Number 2, sketch the image of triangle ABC after dilation from the origin by a factor of 2. So what we can do is we can take, if it's a dilation from the origin by a factor of 2, oh, this is nice. We just multiply everything by 2. So this is -1, -1. Our new A prime is going to be at -2, -2. This point is -4, 2. So -4 becomes -8. 2 becomes 4. This one is 3, 4. So what's the new one going to be? 6, 8. So that is our A prime, B prime, C prime triangle. Now it says find the length of A prime to B prime. From A prime to B prime. They want that length. We got options. 1, we just count. Okay, this goes over 6 and up 1, 2, 3, 4, 5, 6, 7, 8 goes over 8 and up 1, 2, 3, 4, 5, 6, up 6. So we could just use Pythagorean theorem with 8 squared plus 6 squared. Take the square root, we get 10. Or if you wanted to, you could do the smaller version and then multiply it by 2. So 1, 2, 3, 4 squared plus 1, 2, 3 squared, which gives you 3 squared plus 4 squared is 5, and then you take the square root, you get 5. So either way, then you double it. All right. For C, they want us to find the ratio of the new CA side divided by the old CA side. So Pythagorean theorem again, baby. 1, 2, 3, 4, 5, 6 squared plus 1, 2. 6 squared plus 2 squared, right? And then take the square root. And for this guy, it's 1, 2, 3 squared plus 1 squared, and then take the square root. 6 squared plus 2 squared, 3 squared plus 1 squared, square root, divide them, you get 2. What do you think BC to B prime C is going to be? No. BC to B prime C prime, sorry, this one up here. That compared to that. And it says BC, so the original guy, the smaller one, divided by the longer one. Well, this guy goes over 1, 2, 3, 4, 5, 6, 7, and down 2. So 2 squared plus 7 squared. And then this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then down 1, 2, 3, 4. So 14 squared plus 4 squared. Handy dandy calculator. It's 1/2. Bada bing, bada boom.